Can you switch off? Okay, good morning, participants. I hope you had a good evening yesterday. We are going to start off our session. We sent an exercise in addition to the data sets and presentations for today. Within that exercise, we would like to select 2 people who attempted the exercise so that they can present and others can learn from them. So if you did the exercise, you can raise up your hand and then I will select you and Dr. Amitu will give us permission for you to present. Thank you very much.
Amina, and then Gaspar.
Yes, good morning.
So Amina has already been promoted, so she can go ahead.
Can I share my screen?
Yes, you can share your screen.
Okay, thank you.
But I did not receive material.
Can you see my screen?
Yes, we can see the screen. Go ahead and present.
I talk about how I did it. Excuse me, Professor.
Please go on.
Okay, good morning once again.
Can you raise your voice?
Good morning once again. Are you getting me?
Little, you can increase, move near the laptop.
How is it now?
Good, you can go ahead.
Okay, thank you. I started by reinstalling the packages as an exercise and calling them, by attaching them by running those libraries, and then I imported the employee data. It is sent in the CSV. I converted in XLS. And after converting it in XLS, I came here to import data from Excel. I browse it. My data is saved in the Reform or training folder in new volume D on my computer. I renamed it as employee data set. I click on it and open it. I get this. This is the, if I use it, I wanted to import it manually, I should have used this script. And then I import this is the data set imported in R. After that, I tried to ask for the structure of my data set by typing this script and learn it. I got this structure, meaning my data set is having 474 observations and 10 column of variables. Thank you.
Okay.
Can you explain? Sorry, Bin. Can you explain the structure?
Sorry. Amina is muted.
Someone can help me to explain the structure. I missed it.
You can have the second person.
Can we have the second person present?
You have Adentun.
Thank you, Amina. That was good job done.
Thank you too.
The next person can be Adedantan. Is it Adedantan?
Anybody ready to present?
Yes, Prof. Good morning.
Okay.
Good morning.
If you're ready to present, raise up your hand. Can you hear me?
Yes, I can hear you, ma'am.
Okay. Who is going to present?
I'm Adedunton.
Okay, thank you. Go ahead.
Thank you very much. Yeah, good morning to everyone in the house. I want to start by saying thank you very much for yesterday's session. I saw the assignment this morning and attempted to, the question was that we should import a data set named employee into the RStudio. And the procedure I followed was to first download the document and save it in my referral training folder for day 2, materials for day 2. The first time I tried to import it, I got an error message, and then I noticed that it was received as a read-only file. So I went back to name it as employee with a capital E. And then I came to this import data. I first of all went to session, set the working directory, chose the directory where the file path, where the file was saved. And then I came to the import data set. I imported from base. So it took me to the root folder from which I selected the file employee. And I was able to see that it has 474 observations of 10 variables. I also attempted to run a few commands on it, like the structure, number of rows, number of columns, but I'm not sure I got the structure quite well because the feedback was just 474 observations of 10 variables, and then it started to name them, the ID, gender, all the way to minority. Thank you very much.
I wish you can please reshare so that we can talk about the structure.
Yes, ma'am. I'm sharing.
Yeah, thank you. Is the output visible in the console window?
Sorry, can you come again, please?
Can you see the output of this data structure? There is data frame, 474 observations of 10 variables. Is
Yes,
it visible to everybody? Can I see in the chat people saying yes or no? Okay. If it's visible, let's just talk about the structure of the data set from what my colleague said yesterday. when you get a data set, thank you very much. Let's pay attention. When you get a data set, you want to know how many observations you have, how many variables, and the type of variable, because the type of variable determines the type of analysis. So you can see from the data set employee, there is ID, that is identification of the person. Then we have gender, and it has CHR, meaning character. But if we want to use gender, we have to change gender into a factor. A birth date, we also change into a factor. So whatever was presented as text, R reads it as a character. But if we want to use it for analysis, we change this to factor. Then you can see education, because it's numeric, it is has a structure of INT, meaning interval. So that one is okay. Job category has 3 categories: clerical, manager, and you will see custodial. So it is named as a character. So as today we try to use this data set, we are going to change the characters to factors so that we can be able to use them in the analysis. So I can see that she has already typed in as factor. Okay, let's see whether it will run. Then you can put in a job cut. Okay, then another one. Can you put in as factor, then employee, $, job cut. Yes, but you didn't assign an object to these rows. So you need to assign an object, like for example, where is that changed variable going to be found? So probably we could go at the beginning of each row of the command and put in employee is equal to as a factor. Go at the beginning.
Like this?
No. Delete that. Go at the beginning as a factor dot factor. As dot factor up there. No. Don't type again.
Oh, it's not.
Can you know where there's n row column? Then go to the second row of your code, which starts with as dot factor. No. Remove that space, please. Sorry about that. Yes, there. Where you had put your cursor, then put employee. Put employee, yes, employee, $, gender, then assign.
How do I do
that
that?
less than sign, put the less than sign, then the dash, or you put equals.
Equals.
Yeah, you put equals. Then run that. Can run. Did you run? What is happening in your console window? Put a cursor in your console window and press Ctrl L to clean it, the console down here.
Okay.
Just put the cursor in the output and press Ctrl L.
Okay.
So now we can run and see what happens. Oh, you've entered. Please. Okay, that's great. Okay, it has worked. Then also that one, write employee employee, $, birth date. I hope everybody is watching, then equals, then run. Okay, then employee, $, job cut. So what we are trying to do is to convert the characters to factors. Equals, then run. Run. Then come down, delete that as factor and put structure. Delete it, put structure employee, in bracket employee, open bracket, yeah, employee. Okay, run.
Okay.
You run.
Yes, I have.
Okay, so if we can all pay attention to the console window, you can see that gender has now changed to a factor, birth date has changed to a factor, even job cut has changed to a factor. Okay, so now your data set is ready to be used for analysis. You've converted all characters to factors, and the computer will recognize them as factors and use them as categorical variables.
Yes,
Okay.
Choma. May I ask a question, please?
You have a question? Go ahead.
In the console window, the job card still has character indicated in front of it.
A job cut is down. You can see it down here. You know the way you named it in your you see down here.
Oh, okay.
You renamed it.
Oh, yeah. Sorry about
Yeah. You didn't use the correct variable name, so you can go and correct that and rerun it later on.
Okay, thank
Yes. Okay. Yeah, and then when you run string again. So now job cut has a factor, okay? So I hope that is clear to everybody. Now you know how to bring in data set, you know how to check the structure of the data set, you know how to convert variables from character to factor. So now I hand you over to Dr. Helen. She's going to finish what she didn't finish yesterday. And then for those who have not gotten the material, I'm going to be posting it in the chat. Okay, so thank you very much, presenters, and I encourage, we on the same exercise, we have exercise for tomorrow morning. So please make sure that you do the exercise for tomorrow morning, and we will expect different people to present. Okay, thank you so much. So over to you.
Okay, thank you, Professor Susan. I just want to confirm if you can hear me very well, then I continue. Can you hear me? Please type in the chat if you can hear me. Okay, great, thank you. A very good morning. Hope everyone is well. Thank you again for joining us today. Today we are going to, thank you so much the presenters that have really shown that you've been able now to import data. So we are continuing from what we had yesterday, and today we are going to look at data manipulation. All right, having imported your data into R, at the same time, the moment it's successfully imported, there are some few things that you need to do about your data before you completely dive into the analysis, because at the end of the day, data cleaning is important. Most of the time, the stages of data analysis, especially when it comes to coding and cleaning, but then thereafter, the moment the data is ready for analysis, then that was very easy. So what we are going to do in the manipulation, we are going to do, how can you create a variable? Because depending on your data set, you can do a lot of things with it. So we're going to see recording an existing variable, renaming columns, getting subsets. Then what if there is a certain column that you're not interested in and you want to delete it from your data set? We'll look at the level of measurements. How do you deal with missing values? then emerging data and descriptive analysis, just the beginning ones, and then the rest we'll look at them as we move on. The first thing we are going to do is creating a new or adding a variable. Given that now you already have a feel of what our programming is all about, of how to code again, I'm just reminding you that in case we are creating a variable, we are assigning it a less dash. If you don't want to use a less dash, you can use an equal sign, like how the presenters have shown us. So sometimes you can have data, but still from the existing data or the data they have collected from the field, you can go further and manipulate it. So for example, when you look in our data set of salary, we had a column, we had a salary column, but from the salary column, you can go ahead and maybe you want to create another variable that gives you half of the salary. You want to get a half salary column, whereby you want all the observations to be divided by 2. In that case, you're creating a new variable. So what I do, I'm going to first discuss this, then later we go to R, but just have a feel of what we are going to do there. So when you have salary, you can create a new variable called half. That is what I mean by adding a variable. And then I assign that it's less or equal as an assignment. And I'm telling R that from my data set salaries, okay, go to the salary column. If you remember, how do you pick a column out of the big data set? We use a $sign. And then everything you divide by 2. So that is how I'll be able to see to get another column. Okay. There is also the part of recording an existing variable. Remember, when it comes to analysis, you can convert continuous variables to categorical variables, but the reverse is not true. It is only from continuous to categorical. So still sometimes maybe you have a certain analysis that you want to carry out. For example, in this case, I said, because my salary variable, it is continuous in nature, I can say now I can convert it to a categorical variable by only considering 2 variables. For example, a professor having a high salary or a low salary. Of course, you can, categorize it as many times as you want, or to 3 levels or to 4 levels, depending on what exactly that you want to do. But this was just this is just an illustration that can help us to get this knowledge, and then we apply it to the rest of our data sets. Okay, we're also going to look at renaming columns of a data set in R. What we shall be doing, we'll use the rename command. I'm briefly going through this such that we go to R and we do it practically such that you see how does it work. And then on the subsetting a column or rows, sometimes, for example, you want to deal with maybe, let me give just an example. If you're having sex, and in sex you have either male, and then a female, but then in the analysis that you want to do, you want to only deal with the females and leave the males out. So in that particular case, what we shall use a subset command. Now in this particular case, I used for the case of the rank. Remember, in this data set, the rank, somebody is either an associate professor, an assistant professor, or a professor. So what I decided here is that I can use the subset command. I tell R that I want to create another column. I want to create, now in this particular case, it will be a data set whereby I'm only dealing with professors only, because from a big data set, you can still go ahead and subset and get a smaller data set. From the word subset, it is within the big data set. So I tell R that I subset, okay, from my data set salaries, I go to the variable that I'm interested in, which is rank, that only get for me the data for professors only, implying that the rest of the data for the associate and then assistant is going to be left out. But we're going to still see that in R. All right. This is then also you can use this command salaries if you want to delete out a column or a row. All right. And what we do in that case, we'll use the select command. So what you do here, you get a subset. Inside the subset command, you put the name of the data set, in this particular case, which is salaries. But then you tell R that from salaries, please delete out the column I'm not interested in. In this case, for example, you can consider half a salary and you delete it there. You can even delete as multiple columns as you want, depending on how you want your analysis to be. We talked about the level of measurements in R, and we had a field this morning. How do you use as a factor? In case you've got categorical variables, you have to alert R that when you come to variable gender, please look at it as a factor, etc. Okay, and then I discussed this already most of the time yesterday about numerics and then the integers. And then how do you tell that I'm working with an ordinal variable? Because when it comes to level of measurements, it is either a nominal variable, which is also categorical in nature, and there is no ordering, or it's an ordinal, which has ordering, and it's also categorical. Or it's either numeric, and we can term them as a scale, or it can be a ratio or an interval. And we had a feel of what they are yesterday. So we are going to also to look at how do we deal with missing variables. But what we are going to do in this particular case, we're only going to learn the basic commands, all right? You know, most of the time when we go to the field, sometimes this is inevitable that you'll come up with incomplete responses, especially maybe for some people who have gone ahead to collect data using online surveys. One of the biggest disadvantages of using online surveys is that most of the responses that you get there, you've got an incomplete result or responses, missing values or missing data. How do you deal with that? When we move to R, we shall see that most of the time, the missing variables are coded with a symbol NA. NA meaning not available. So how do you identify that this is a missing, that your data set has got missing values or missing responses? When we move to R, we are going to use a command is.na. Okay, you're asking R to show you the missing variable, the missing values within your data set. And also, but luckily enough with the salary data set that we are using, there is no missing data. But this is just a feel that you can have. What happens in case, in practical sense, your data has got missing values, okay? And so when you look at this particular example that I'm showing, it is just a small data set which has got only 3 variables. I've got the name, the sex, and then the age, all right? And the first observation, the first person was John, the sex is male, and then 45 years. The second person is Tim, they give the sex and then the age. However, when you come to the third observation or the third person, we see that it is NA, so meaning that not available. Somebody went collected data but not capture the name. But interestingly, or when he was filling in the responses, he managed to fill in his sex and wasn't conversant or never wanted to fill in his age. So still in age, you've got NA. So most of the time when you import your data in R, wherever there is a missing value, R will read it as NA, not available. So when you move on and use this particular command, is.na, and you put in the name of your data set, what R does, you're going to get an output. Where the values are available, it will put false. But where there is a missing value, it will put true. Usually the output, it gives out, it's a logic, false or true. So where there is a data set, for example, a value here, there is John, it will bring false. That where there is false, that the values are available. But where there is true, that's why you get to know that, yes, my data has got some missing values. So, and we are going to look at only the basics. How do you omit out missing values? However, it is also important to note that, so we shall use, sometimes you can have a lot of data, okay? And then you're like, no, I want to only use complete cases. I'm going to do away with these missing variables. So how do you deal with only complete cases? When we move to R, we shall only be using, we shall type in na.omit, meaning that wherever you have a variable, a value that is missing, kindly omit and bring me a clean data set that has got only complete cases. Looking at this particular example, we see that in this data set, when you look at the second observation, there is NA missing the sex of the observation. When you come to the third one, we also still have NA, implying that that value is missing. We don't know the name for the observation number 3. So in case I use NA.omit, then I put in the name of my data set. I'm commanding R that leave out all that is missing and give me only the complete cases. So R will return only this particular person, the first observation, because it's the one that is what? That is complete. We are going to practically do all these things. However, it is also good to note that apart from dealing away with missing data from the data frame, we are just looking at the basics right now, but there are advanced methods that you can use to impute missing data. Because by the end of the day, if a lot of data is deleted, most of the information will be lost, and we will be losing a lot of information that would support us to make the decisions that we want. So in this particular case, imputing methods can be used to avoid losing a lot of information through missing data. And then the other thing that we're going to look at is emerging data sets. Most of the time when we go to the field, sometimes we collect we collect data differently. Maybe somebody can collect data from a different Excel sheet, another one collects data from maybe a different computer. So you can tell a colleague that, you know what, can you send me that data set? And by the end of the day, you want to emerge these particular data sets. You put them together. So it is also important when it comes to data manipulation to see that the data set that you are using, it's complete, okay? So still, there are very many methods you can use to emerge data. We are going to look at the simple ones. If you look at the PowerPoint that I sent you, there are various methods that you can use. You can use R gives you an example. You can use a merge command, whereby you put in the name of the data set, the first data set. For example, in this particular case, you can have 2 Excel sheets, okay? You name one data frame A, you name the other Excel sheet data frame B. However, it is important to note that most of these data sets, if you want to join them, they should have a unique identifier. So what are you joining them by? You're joining them by what? Okay, we are going to go into details and see an example using you're doing it practically in R. So you can use the merge command, or you can use the R bind command, whereby in this particular case, when you're using the R bind command, you're trying to put data vertically, okay? You're combining it vertically. That's why it is R. So these 2 data sets, they must have the same variables, and but not necessarily the same order. Okay, then also the other commonly used commands when you want to join data, okay, it's in the dplyr function, in the dplyr package, which I believe that now we've already loaded it and we've uploaded everything. So under the dplyr package, apart from supporting data manipulation, in data manipulation, we can also, the moment you load that package, it can also support you in case you want to merge different data sets. So we've got a command which is left joiner, the right joiner, the inner joiner, and then the full joiner. We are going to see how these data sets, how these commands are used in R when we go to the salary data set. All right. So with the left join command, what it does, it emerges the 2 data sets, but keeps all observations from the original table. What do I mean? Assuming you have data set A and you have data set B. In data set A, maybe you have 5 observations, and in data set B, you have 8 observations. What it means that it keeps all observations from the original table. It is going to keep all the observations in the data set A. And this would, when you come to the word right join, you have to note this particular word, that it keeps all observation from the destined table, implying that that is the second data set. And then with the inner join, the way you hear the word inner, that is the intersection, all the common ones in both the data sets. And then the full join, what it will do, it will just emerge everything from the first data set to the second data set. And it's also important to note that you can merge as many data sets as you want, depending on what you're looking at. Just a brief example. Let's take an example. When I talk about left join, what should come at the back of your mind? For example, here, I've got this data set, which is table A. I've got an ID and then a Y variable, okay? And then table B with table 2, which is my second data set, I've got an ID and then I've got a Z variable. Remember what I said, this particular data set, they're supposed to have a joiner, something that is common in both. You find that in data set 1 called table 1, it has got an ID. And then in table 2, which is my second data set, it has got an ID, which is now the common one with the other variables Y and then in the data set, this other one has got the Z one. So in case you use the left join, it implies that it is going, my first table, this is for table 1, is then the first one, and then table 2 is the second one. So it is going to consider this first one. It's going to pick up all the observations in table 1 and then join them with the ones in table 2. What does that imply? When you look at this one, it has from A, B, C, D, and then F. But when you come to the second data set, it has A, B, C, D, and then E, implying that E is not in this, is not in the first data set. So it will be left out. It is going to get the whole of the data set and it will going to get A, B, C, and D because it's what is common. It's going to get the data in this particular one. It emerges it with table 1. So at the end of the day, this is the output. Table 3 is going to be your output. We've got all the data sets in table 1. That is my data set A, in addition to variable Z. But in this particular case, F never had, it wasn't an observation in table 2. So it will indicate NA, not available. That when you come to Z, when you come to data set 2, the Z column does, when it doesn't have the F observation. So that's why it is putting NA. And how are we going to do that? We still use the left join. You've indicated the first data set. This is DF primary, that is the first data set. DF secondary, that is the second data set. And then by, it means that what are you joining it with? What is the common joiner that you're using? We are seeing that in this particular example, we've seen now we are having ID in the first one and then ID in the second one. So we'll join by the ID to bring them together. So that is the left join. When it comes to the right join, now it is the opposite. Okay, so all the data sets in data set 2 will be maintained and will be merged with the common ones in the first data set. And then we come up with the output. All right, then with the in join, it implies that just combine for me all the common observations in both data set 1 and then data set 2. And that will be the output that I will be getting. When it comes to full join, you're commanding R to join up everything, okay? For example, my table 1 has got A up to F, and then this one has A, B, C, D, then F. So it is going to bring everything together, but where there is a missing value, it will put NA, implying that it is not available. So we are going to move to R and see how these things work out. With the descriptive again, we shall do it in R, just a simple descriptive and then the graphics. So let me pause in the chat and ask, can we continue with can we go now to the survey data set and see how we can do data manipulation practically, given that now you have a feel of what exactly we are going to do. All right. Okay, I'm going to stop sharing that. And now I'm going to share my R script. Please also, that side, open your R Studio open your R script such that we move on to the same page. It's what I'm doing as well. So I'm going to share. Okay. So I want to confirm if you're seeing now my R, if you're seeing my the R Studio. Are you seeing the screen properly such that we continue? Okay. Now, we are now, how do we do it in R? Having gotten a feel of what is really happening. Remember, we said that the moment you have the data, you can do anything, whatever that you want to do with it, depending on the set objectives. Your objectives are the ones they are the ones that do guide you as you're doing the data manipulation. Okay. Okay. Just a slight communication. Professor Susan is saying that he's seeing a lot of comments in the chat, and people are saying that they did not receive the material. So now what we are going to do, please stop posting anything. She's going to put the materials in the chat room. So don't post anything such that everyone is able to pick them from there. Okay, don't write anything in the chat, because as you keep writing, then you're going to miss the materials. As she posts the materials in the chat, for those who never got, kindly just pick and let also the rest get the materials as well, such that we move on the same page. So she has started posting. Thank you for your cooperation. Okay, so let's continue. We are creating or adding a new variable. Remember how our data set looks like. Okay, let me go back a little bit. What we need to do, since it's now a new day, what I'm going to do, I'm going to load my libraries. I don't need to install them anymore because they're already installed on my computer. So what I need is just to load the library, and then I continue with the work that I need to do. Okay, I set my working directory. I'm so happy that now everyone can import data into R. It's what I'm going to do. Then what I do, I'm importing my R data set. So I've called it salaries. It's what we had yesterday. I come and check in the environment, and I see that yes, it has got 397 observations and 6 variables. So now I'm going to move, I can ask what is the string that is str, that is the structure of my data set, the structure of salaries. And so what is showing me, this is what our presenters were showing us this morning. However, I need to convert character, discipline, and then sex into factors, okay? So what I'll do, I'll use my commands as a factor. Most of the time when you're signing an object, for example here, that salaries, then $rank. What that implies is that you're telling R that go into my same data set, okay, salaries, consider the rank as a factor. That's why it is always important to do the signing, because initially it is looking at it as a character. So I run that. I do the same for the discipline. I do the same for the salaries, for the sex. Now I can check again to see, has the computers R done what I wanted it to do? And when you check again with the structure, it has observed that. So now you're good to go. Let's continue with the manipulation. So if you want to create a new or adding variables, remember at the back of my mind, what I want is to create another variable called half salary. I'm calling it half salary. So this is the new variable I'm creating. I'm attaching it to salaries because I want it to be a new column in that data set. That's why I'm having salaries, $ half salary. It is a new variable. Now, then I come and I say that this one will be equal to salaries, $ salary. I want to get half salaries. So it implies that I'm going to go in the column for salaries and I divide everything by 2. So in case I run this, okay, when you look closely in the environment, initially they were 6 observations. Now, when you look critically, we see that they are moved from 6 to 7 observations. You can as well come and click here and view and see. You find that now you've got another variable that is added, which is half salary. What it did, it was to get all the observation under the salary and divide them by 2. So this is the half salary for each observation. So you've created and added a new variable in your data set. There were 6 observations. Now you've increased them to 7 observations. Okay, let me ask in the chat, is that, not yet. Okay, I'm told they are still posting the material. Let's continue then now. I will ask as we move on. Now, if I go back to my salary, all right, I've already clicked that view, I've seen that. How do you record, for example, recording an existing variable? Re-recording, for like I'm still using the salary. Salary is my output. We are looking at different factors that affect the salary of professors from the attributes that were collected, from the different variables that were collected. And so with re-recording here, what I mean is that maybe, for example, we want to receive still from this salary variable, you want to see those who are getting low salary and those who are getting a high salary. Remember, this is just my personal decision, but you can also have your own decision. So what I do, sorry. So what I do, for me, the criteria that I use, I decided to first get to it because it's a continuous variable. In us, you can use the command summary to give, when you're dealing with continuous variables or numerical variables, you can use, in descriptive statistics, you can use summary. So when I use the summary command and I go in my data set, I get salary, then $, salaries is the name of the data set, and then salary is a column that I want to consider. So if I run that, you find that when you look in the console, what I'm having is that I've got the minimum salary, I've got the first quantile, the medium salary, the mean, the third quantile, and then the maximum salary. That is what the data set is showing me. So I'm like, okay, I'm going to consider whatever is less than the mean, whatever is less than 1,137.06, I'm going to call it low. And whatever is so, and then whatever is above that, I'll call it high. Like I said, this is just a decision the decision is guided by the objective that you want to achieve. So in this case, if you want to convert a continuous variable to a categorical variable, we use an if-else command. If you're looking, so can I ask in the chat now? Read R. Now, there are some people who are asking questions about how to download. We covered that yesterday. Kindly, let's just concentrate on what we are supposed to look at today, and then you can move on to that. I'm getting an error in summary. If you are getting an error, it implies that you did not import your data set. Kindly, I'm just giving you just a few minutes. Import your data, run the libraries, all the libraries we had yesterday, you load them again. Don't install because they're already installed on your computer. Run the libraries again, import the data set, work salaries.csv or XLSX, depending on whatever that you want. Okay. The moment you've imported that data very well, then it implies that you're not going to get these errors. Cecilia is asking that I elaborate more on the sign, the dollar sign. The dollar sign, it implies that you want to tag something. For example, we are looking at salary data sets, okay? But within salaries, we've got different variables. For example, we've got the rank, we've got the years since PhD, we've got the years of service, and then the salaries, the salary that is being received by every professor. So how do you call upon one particular column or one particular variable? To do that, we use a dollar sign. For example, you can say salaries $rank, implying that you're telling R that I'm only within my data set salaries, I'm looking at rank only, and the same applies to other variables. So is it possible to get a recording of yesterday? Yes, all that will be gotten. Explain the process of converting continuous to categoricals. That is the only one that I'm going to explain, and then I push on. Most of the time, when you're having a continuous variable, there are many different examples that you can consider. Okay, let's say numerical variables. Talk about the weight, talk about the temperature, talk about the climate, and so on. All those are numerical variables. You can convert numerical variables or continuous variables to categorical variables. Let's take a simple example. Assuming that maybe a lecturer is recording the marks for the students, and within the recording sheet for the different students, the marks that we get, 80, 60, blah, blah, all those are they're just numbers, okay? But you can convert them to categorical, you can convert those, the different marks into a categorical variable. For example, maybe you can say those who passed and those who failed. So depending on the criteria you're using, maybe you can say below 50, let them belong to this category that they failed. Then above 50, they passed. Or you can still categorize them into 3 groups. And you say maybe those between 0 and 50, they belong to category of failures. Then between 51 and 70, maybe you'll give them, they belong to a B category. And then above 71, you categorize them as A materials. So that is how it works. Okay, let me pause again in the chat. Can I proceed? Can I continue? Have you been able to import everything? I mentioned yesterday that R is case sensitive. So you have to ensure that whatever you carry from the start, it's what you continue with. Okay. Let's continue. So we're looking at a step where we can convert a continuous variable into a categorical one. Like I say, this is guided by your objective. So to me, I said I'm going to convert salary into 2 categories. Salary is my main variable. but it has got two attributes, low and high. Whoever gets below the mean that I got from the summary command, he will belong to the low category. And whoever has an amount higher than that, R will put him into the higher category. But I said, in that case, we use the if-else command. This one. Okay. We use the if-else command. If you're seeing my screen very well, there is a yellow pop-out, okay? Which tells you that first you put the test that you want, okay? What do you want to test? And then there are two options, a yes or no. So in this particular case, my test, I said that whoever professor is getting less than the mean, let them be categorized into low, that is the yes. And then the rest, the ones that are above that, let them go into the no, and that is the high. Okay, in case you need more information on how to use these commands, remember we said yesterday, you can use the help command. For example, you can come and say help, and then inside you put if else. And after putting that, R will support you to tell you, okay, in case you want to use if else, this is what it does. Okay, you can even see here, it is telling you that it returns a value with the same shape as a test. Or if you don't want to read it like that, you can click at the end of the line and click run. When you click run and you come under here in the help window, you see that there is a lot of information that has come up, whereby it is explaining to you, how do you use these commands? Okay, this, how do you use the different arguments? How do you put it? The more they give you more details, and then at the same time, they support you with examples that can support you to even understand more. All right, now from there, it is always important to use the help window most of the time, to use the help command to support you to understand what we are doing. So I'm going to go back. What I did again, that when I categorized my variable salary, okay, I told R, now I'm naming it a new variable, which I'm calling salary cut. Salary cut, that is salary cut, is I got it from categorize or categorical, and I only took the first three letters. Most of the time, it depends on how you want to rename. That will help you quickly to remember what exactly you want to do. So I said that within my salaries data set, create for me a new variable called salary cut. But within this salary cut column now of the new variable, I want R to categorize for me. That's why I use the if else command. The professors that get below 113706 to categorize them as low, and then those that get above to categorize them as high. Okay, now I'm going to run this line. If I run it, I look in my console and it tells me that I've written a right command. So how do I know? How do I check that to see whether it has worked or not? What I can do, you can go in the environment again. You see that now we had 7 variables, but now they have increased to 8 variables. You can come and click on the Excel sheet icon. The moment you click on it, it brings view. So as you move to check, you find that your last column now, it is salary cut, and it has been able to group for you that whoever professor is above the mean, he has put them into the high category, and then those that are below, they're grouped under the low category. And so that is our new variable. So maybe, for example, in case you're moving on and you want to do a logistic regression, you can consider the salary cut, because in that particular case, it is the outcome will be categorical in nature. Yet, if in case you're using the original salaries that we had because they are numbers, then you can go into a linear regression. So, I mean, it all comes about that what method do I want to use by the end of the day? So you drive your data in that direction and the objectives that you want to achieve. Let me go back to the chart and ask, are we on the same page? Okay, great. All right, now let's continue. So we've seen how can you change a continuous variable to a categorical one. But remember, the opposite is not true. You can't run from category back to continuous. Now let's move on and see how others work. Sometimes you might want to rename your columns. Maybe during the data correction, you gave it a wrong name, or you want to give it something that might be familiar to you. Okay, this is the whole instance of what we are doing. So in this particular case, we use a command rename. Okay, you want to rename something within your data set. Where do you want to rename? If you see what has popped up, the yellow one, it tells you start with data. But remember, I named my data salaries. So I want R to consider my data set salaries and then rename. Okay, because when you look at the data set, maybe let me show it to you again. When you look at our data set, you have got rank, discipline, years since PhD, years of service, and then sex and salary. Sometimes you might want to rename these columns. For example, maybe here we are saying that sex in small letters, but you want to rename it to capital letters. Or no, you might say, no, I don't want to use the word sex. I want to use the word gender, okay? I want to rename it to gender. So all those things work here. You can be able to rename it to what you feel really projects what you're going to achieve by the end of the day. So that's what the rename command does. So here I said, I want to rename where there is sex, I want to name it with capital letters. Or somebody else can say that, no, name it gender, because for me, it's a word that interests me most. And then when you come and run it here, you click and then run that line at the end. So how do you see that the name has changed? You can use the call names command, okay, this one here, to check whether the names have what? Call names. It implies that it is going to bring you the column names within your data set. So, and what is our data set? It is salaries. So if I run this line, what is going to happen is that when you look in your console now, it brings all the names of your data set, okay? All the column names, all the variables in your data set. But this time around, it has changed the naming for sex from small to capital. You can even change it to another name. Maybe you want to give it gender, and it will give you that, okay? Now, the other manipulation that we're going to look at is subset, okay? Like what we looked at earlier, for example, we've already seen head. Most of the time we use head to first see part of our data set, maybe the first 6 rows of our data set. We saw that yesterday, okay? But now I want us to use the subset. The example that I gave, for example, maybe you've collected data. And within your data, yes, you've got a variable sex. Under sex, you have males and females. But your interest is just now only to deal with females, not with males alone. So how do you do that? You subset. From the big data set, you can say, now I only want to deal with this particular group of people. Within the data set that I sent, I picked interest with working with the variable rank. Under rank, remember, it is a factor. It is a factor. It has got 3 groups. It has got the assistant professors, it has got associate professors, and it has also got professors. But I say that now, this time around, I only want to deal with one group of people who are the professors only. So I'm going to command R. This is what I'm going to do to only give me the data set that belongs to only professors. It is a subset command that we use. The way you hear the word a subset, it is part of the main data, but this time around you want to deal with a certain category of people. All these things that we are looking at, it applies in your various fields. Okay, maybe if you're within maybe you went to the field and dealing with different plots, you might say that, well, I want to deal with only plot A and first do away with other plots. So this is what you can quickly apply. So coming back to the data set, using the subset command, I tell R that from my salaries data set, that is the main data set, go under the rank variable. Okay, pick for me only the data that belongs to professors. Okay, so I come and quote professors only. In case I was interested in the associate, I would put that or assistant. But since it is just okay, I'll recap, but first listen. Okay, so since it is part of the main data set, I want to give an object which I call salaries prof. Okay, I used salaries prof, implying that I want now the new data set that I'm going to get, the subset of the main data set that I'm going to get, whereby it only has professors only. Okay, so what I do, this is like I've explained earlier, this is what I use. What I do, I run now the line at the end. When I run it, interestingly, look in your environment. When you look in the environment, now here we've got another name of the data set has been created, which I called salaries prof. Now it is telling you, now the observations have reduced. So now they are 266. Of course, they're the same observations. If you want to have a look now of how this looks like, you can click on the Excel icon. When I click there, what happens? Look at the rank. You find that now this time around, under the rank, it only brings one category. And this category is for only professors, implying that it removed all the rest of the other groups of the associate and then the assistant. And now this is the only data set that applies to only professors. So you can still use this and deal it as a separate data set and do the analysis that you are interested in. Okay, I'm going to pause and ask in the chat whether it is well or I need to recap. Okay. All right. Yes, from what I'm seeing in the chat, people are telling me that yes, I proceed. Professor Susan and Dr. Thomas, kindly share the material. People are still complaining about the material. Okay, fine, thank you. Let's continue. All right, now back to the salary data set. As we are trying to do, I would like to kindly bring to your attention, as we are trying to do the different commands, or as we are trying to do the manipulation, always draw your mind to the personal data set that you're going to collect, or some of you even already have data sets. So it is always important, like, okay, how do I get this particular knowledge and now apply it directly to my data set? So it's because, remember what we said, that the codes that we use in R, it is important to understand them because they are reproducible. You will not be able to reproduce them unless you know what each command implies, and that's how you would collectively use it in your data during data collection or during data analysis. Okay, so that is that. I've already talked about the view. Yes, we can do that. Now, I'm going to go on another DM5. How do you, because now when you look at our data set salaries, if I show it again, you find that initially we had 6 variables, but now right now we've got 8 variables. Remember the ones we added a half salary, and then we also added salary cut that we categorized. So sometimes as you are doing the manipulation or you're working, you might reach somewhere and say like, no, within this data set, I want to do away with some of, I've used the half salary, I'm no longer interested in it. I've used the salary cut, I'm no longer interested in it. So how can you delete it off from your data set and remain with what you want? So back to our salary data set. So what we do, again, I'm still using our salary data set. So this time around, what we do, we still use our command subset. Okay, the subset command. Inside the subset command, I tell R that go to my data set, which I named salaries. I use an argument called select. Select is equal to, this is what is going to support me to remove the column that I'm not interested in anymore, or the variables that I do not want. So what happened is that there is a minus sign here. Hope you're seeing it. There is a minus here implying that reduce, minus, or remove. The C means to concatenate, bringing together. The C will mostly work in case you want to remove many variables, or you can delete it, but the minus have to be there. And you're telling R, remove the column or the variable have salary. I'm not interested in it. Okay, so you come and then you close everything. Everything is inside the subset variable. Okay, under the select argument, I've told it, remove for me. I don't want to see the half salary. Okay, so when I run this command, now, when you check now again, in your environment, we had 8 observations, now 8 variables, now they have reduced to 7. You can come and check and see. So when you check, you see that one of the variable that you are in, the half salary has been deleted out and you don't have it anymore. It has gone because you told R to delete it. So sometimes you might be interested to delete as more columns as possible. So with the multiple ones, what happens is that you just need to put what you want to delete out and then create a comma. You put another variable, create a comma. Even if there are 10 of them, you can delete them at a go. So in this next command, where I've got still subset, I'm telling R again that please remove now the salary command and remove also the salary cut. So as you minus, it implying that when you go back to view your salary data set again, whatever you've removed will not be there. So in case I run this and I do that, you see that now this time around, my variables have reduced to 5. In case I want to view, you see that other columns have been deleted. All this is data manipulation. Okay, so with the level of measurements, like I mentioned, I discussed that earlier. And then the other one is dealing with missing data. Before I move to missing data, let me still get the chart and inquire, are we on the same page? Okay. All right. Fine. Okay. Some are saying that yes, but please reduce the speed. Okay. Okay. View salaries. Philip, it is giving you an error. It has to be capital V, not small v. Please adjust that and try again. That's why it is giving an error. Okay. Kindly also, for now, let's stop sending messages in the chat. Prof and Dr. Thomas, they are going to send materials again. Please pick them. We send materials, but the challenge is that maybe we get to a limit of our emails. It could be the reason some of you are missing these materials out. So they have started sending. Pick the work that we are using, pick the data sets. Stop sending comments. Faith, you're asking about merging data. We're going to look at that. For now, stop posting and they send the materials such that you can pick them. Okay, so within, can you, let me ask in the chat, do you have the missing R script? Can a column be deleted once deleted? Okay. Kindly go into your different folders and open for me the missing R script that I sent, because it's what we are going to deal with. Let me first stop sharing this and I share something. They can't hear me. Wanted to. Thank you. Okay, there's something I want to share just briefly. I'm getting it on my computer. Then kindly check the missing data.xlsx. It's what I want to share. It is something that we can work out together. Check where you saved it, and then this is how it looks like. It's what I'm sharing. It is something very small. I did just a simple data set such that we are able to get the concept behind. I discussed it already in the PowerPoint, but let's still get another feel. So this is the data set that I sent for missing data, missing.data.xlsx. So I used very simple variables, something very small for us to master. And then you have to shift this knowledge in case you've got a big data set. So here I've got a variable name. So under the variable name, there are different names, but you see that this person here doesn't have any name. The name was missing. We have sex, we have age, okay? But still this third person doesn't have the age, okay? So what happened is that we need to know when the moment you import this, how R is going to look at missing values. For it is going to look at it as NA. All right. So now what I'm going to do, you can also do the same on your computers and import for me this data, or open the R script, the missing R script in your R Studio. So I'm going to stop sharing this, and then I share again my R. Okay, so this is the script I'm talking about, missing.r. We want to see the basics, but remember we said there are other advanced methods that you can use. So let me ask in the chat, have you been able to open the missing R script? Type yes. Have you opened your missing R script? Okay, great. Now let's continue. So in there, let's load our libraries. We installed these libraries yesterday. So let's just load them. In case they are missing in what I sent you, just type them in or copy them from salary and then paste them in the missing.r script. So what I'm going to do, it is just to run them, or you can even just continue because they are already loaded in the sessions that we're doing today. So what I do, we saw different ways on how to import data. So what I'm going to do, I can go to File, and then I import data, that is Excel. But this time around, what I want is I'm going to bring my missing data.xlsx. So I open that. The moment I see a preview, if you can see within your data preview is that NAR is telling you that that data is not there. It is missing. It is not seeing anything. So what I do, I come and click import. Okay. So the moment I click import, it implies that now my data has been imported successfully in R. You can even come and check in the environment. They are showing 3 observations and then 3 variables. With the method that we learned, you can quickly view what is happening. And this is what we are having. All right. So when I go back to the missing, now that I've imported my data, we just need to do, how do we do the basics? All right. I've imported my data as missing data. When you look here in the environment, it is missing data with 3 observations and 3 variables. But in my mind, I'm seeing that the naming of this data set that R has given me automatically, it is very long. So I want to rename it again, or I want to give it another name. So what I do, I just say, let me use DT, okay? Less or equal, that this DT is equal to missing data. I want to shorten the name, but everything is going to remain the same. So in case I run this, if I click run, when you look in the environment, still you're having 3 observations and 3 variables. Nothing has changed. What has changed is just now the data name. When I click again, it will still give me the same thing. Let me ask in the chat, are we on the same page? Okay. 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 All right. Let's move on. Like I mentioned earlier, that in R, missing values are represented by a symbol NA. NA means not available. Okay, so for us to check if our data, to find missing values, you check for NA in R using is.NA, then in the bracket you put in, you type in your data set, and it will bring you to, so what you do, you type is.NA. Okay, this is the command we use to check, to confirm that you've got missing data in your data set. But inside the bracket, what you type in is the data, the name of the data. So I put DT. So in case I run this line, what happens, remember I said it's a small data set because I want us to get the concept clearly well. Where there is false, it implies that that value is there. But where you see true, it implies that that value is not there. For example, when you look at observation 3, when you come here, you're seeing true. And we saw that that respondent did not indicate the name. And then when you come to age, also they are putting true, they do not indicate the name. But this person managed to indicate the what? The sex, and we saw that it was a woman. All right. I say that most of the time, most of the data where we experience missing data, especially people are doing online surveys, you know, you send out your survey and you tell people, please fill in, there's an online survey, I want to pick these responses. And most of the time, by the time you collect the data, some of them have not filled some of the things that you asked, so they come as missing responses. So sometimes if you've got a very big data set, you can first check to confirm whether you've got missing data or you don't have any missing data. Okay, so that is the logic behind. And then, so depending on what you want on what you are dealing with, sometimes if your data set is very big and you feel like maybe what you're having, if you deal with only complete cases, they'll also support you to achieve the objectives that you set before. So we use a command that is called na.omit, omit, implying that wherever you see NA, not available value, just omit it, delete it out of my data set, and only give me only complete cases. All right. So in this particular case, I can run na.omit, in bracket, I put the name of my data set. So when I run that, you see that now in my console, sorry. Okay, sorry about that. You see that in the console, now I only have complete observations. Or what you can do, you can decide to create a new data set that has got only complete observations. So you create an object name, which I call DT2, and I assign it to only the complete cases. So if I run this line and I look in the environment, what I'm seeing is that I can check again, and I'm only having only I've got a complete data set without any, the missing values. So depending on what you are interested in, you can create a new data set. But like I mentioned earlier, sometimes it is not good to do away with missing data, because if all the data is deleted, it implies that a lot of information will be lost. However, there are advanced methods on how you can deal with missing data. And what happens in R is that we do what we call imputation, but we are not going to look at that now. I was only sharing you with the basics. The imputation will come in later. So that is the part with the missing values. How can you deal with missing data? The basics. Okay, let me ask in the chat, is it okay? Can we proceed to the last bit of merging data? How do you replace missing data? I said with the advanced method that you can use, that is imputation, but we're not going to look at that. For now, you can deal with only complete cases. Okay, great. Let's look at the last bit. And then the last bit is about merging data. Okay, and then my colleague will set in to take us more in what we're supposed to cover today. All right, still in the materials that we sent, I sent you to 2 data sets which had weight A.csv and weight B.csv. Let me check in the chat. Did you get that? Do you have those? If you have weight A.csv and weight B, kindly confirm to me in the chat and I continue. Okay, some yes, some no. Dr. Thomas, can you share in the chat weight data?
Weight, the missing weight.
Mm.
I've been sharing that they keep on pushing the thing. You tell them to stop.
Okay, for now, stop posting anything in the chat. And then they're going to post. No, stop putting comments in the chat. First, download the weight data. Yes, both of them, weight A and B. Okay. Let me first stop sharing this and I show you how the weight data looks like. Please pick it from the chat. Stop posting and pick the material that's those who don't. Okay. This is weight A data. Let me, are you done?
Yeah.
Okay. Please pick weight A.csv from the chart and weight B.csv from the chart. That plus missing. Please pick them. Please pick them from the, just drag from your chart, click and drag it to your computer. There is no magic there. Pick and drag it on your computer. Okay, now I'm showing you how the weight data looks like. Under weight, this was part of the data. I just picked a small part of a data set for illustration purposes, because the moment we understand it, when you have little data, it's quick to understand what I want exactly to put forward. And then it can be, and then you would get what happens in case you've got a big data set. All right. So with underweight data, this was data for children. They were collecting the weight of the children in a hospital. Okay. So, but these kids, they had unique numbers, which I'm calling the IDs. If you have this data, you can also open it on your computer. So every child was given a unique identity number. That is the ID. They were indicating the sex, 2 or 1, whereby 2 is male and then 1 is female. They were capturing the weight of the baby, they're capturing the height, and also the arm size, the arm length. Okay, so this is my data set. I'm calling weight A.csv. Remember, it is part of the big data set, but I'm just picking this out for illustration. All right, so I'm going to stop sharing this, and then I share weight, and then I'm going to share now weight B. So when you look at weight B in the other data sets, okay, still I've got the unique number, the ID, but this time around I've got different variables. In this other one, some of the IDs, the unique numbers, are similar in weight A. But now I also want to add these variables into one data set, because they have indicated the day, they have the day when the baby was born. They have also indicated the what? The month. Most of the time when you go to hospital and you want to collect different data, for example, like the one we are having here on children, so you can pick, they can pick this data from different files. all right? So this data could be in different files, but what
you tell them that they are registered automatically, so there's not enough list.
Okay.
You tell them they are registered, there's not enough list.
Please, for those who are asking if they are registered, you are registered automatically the moment you log on the training. So there's no reason, there's no need for you to worry about that. So can I continue? Weight data is not posted in the chat. It is because you keep posting. You don't want to. They post and then you send in 100 messages at a go and the data disappears. Pick weight A.csv and then weight B.csv. So I'm continuing. Okay, so I'm stopped. I wanted to show you a feel of our data. Now I'm going back to R. How do we bring this data together? So I'm going back to my R studio. All right. So, remember the data is in Excel, so we need to import it. So what I do, because it is, I've already told R I've already set my working directorate. The data that I want to import is within the folder that has on the salary, the work salaries data. So I don't need to create it anymore. So what I do, I run to read my data set. And then you find that when you check here, I called it DF1. This is my first data set, which has got weight A. R in the environment, it has got 11 observations and 5 variables. Okay, then if I run weight B, R is telling me, yes, DF2, it is the name that I've given to weight B. For it, it has got 14 observations and 3 variables. Remember, among these variables, there is a unique identifier in both data sets, which is the ID. Though you can note at the back of the mind that you can have more than one unique identifier. So there is no problem, depending on what you want to achieve at the end of the day or what you want to join to come up with the final data set. Okay, I can, in case you want to see the structure of each, you can go ahead and run it if you're interested. For example, a structure for DF1, that is weight A, it is, I'm almost done. This is the last one. Okay, and then I look for, you see with this one, it is giving me the structure, the ID, the sex, and then the weight. And then when I run the structure for the second one, it gives me that. When you check in the console, that's what it is giving me. So what I'm going to do, I'm going to use, in case you're interested, merging data depending on what you want to do, but I'm giving all the options and then you pick out what you want. We said in case you use the left join, you start with the, as per the command we saw in the PowerPoint, you start with the first data set and then the second data set, my DF2, and then the joiner, what is common in the different data sets. So what happened is that, so my output is going to contain all the observations in the first data set and also join with the one with the second data set. The observations in data set 2 that are missing data set 1 will indicate them as NA. So in case I do this and I run, okay, when you check in my console, this is what it's giving me. You see that now I'm on it, it only gives me 11 observations. But this time around, on top of sex, weight, height, and arm, it has brought together day and month in one set. Okay, so that is the left join. Then the right join, it maintains all observations in the second data set, and then the ones that were not in the first data set, they it will indicate NA. So this is the command I'm going to use, right join. I start with the first data set, I put the second data set, and then what is the joiner. So when I run this again, this is what I get. When I run that, now this is what it's giving me. There are 14 observations, okay, within the second data set. And it's showing me that all these ones, these identifiers from 12 to 14, that it is NA, they don't have, they are variables, all the data is missing. All right, hope you know the reason as to why now there is an NA not available. So that is to the right join. Sometimes you might have to pick only the observations that are in both data set A and in the second data set. So we use what we call inner join. This one here, this command, inner join. You put the first data set, the second data set, and then the joiner is the ID. So the moment I run that, and then I can come and view. It is here. When I come and view, it will only bring me, of course, what you just expect at the back of your mind is that with this one, don't expect missing variables, because it only brings what is common in both data sets, brings only complete cases. In case you want full join, everything combined, so from data set A and data set B, DF1 and DF2, what you do, you run the full join, and then you can come and check and see that now all the data set has been combined together. You can check from the view, and then where we have the missing data, it will remain there. So that is the part in case you have got that different data set that are not joined together. All right, so now I'm going to just briefly look at the last bit of the script statistics, just the little bits. Remember, it still applies to what kind of variable that you have. I can recall my data again, and because remember, I've done a lot of manipulation, I can reread it again, my salaries, I already have it there. Then if salary is a continuous data, it's a continuous variable, you can be able to get the mean, the maximum, the mean, the standard deviation, the median, the variance, the range. So all these are just commands of this from one variable, what you can call univariate analysis. So in case I run that line, okay, so when you look in the console, it has given me the minimum because that is what I asked for first, then the maximum. I'm joining different commands in one line and I'm separating them by a semicolon. Then the mean, that is the third one, and then the standard deviation. So it is what it is giving me, okay? When it comes to categorical variables, it implies that you use a command table. So you use table and then you run. So it will tell you that associate professors, there were 64, assistant, there were 67, and then professors, there are 266. You use the same command table for the rest of the categorical values. Sometimes maybe you want to create percentages. So this is what I've just run here. Or I can create an object here and I store everything. Where I've got table salaries rank, I can store them in an object called ranks. So in case I run that in table, for me to see the result, I need to run the object. So it is the same thing that like I had before. Double quote. You explain.
When you're subsetting, same subset of prof, and then what's
But we moved away from it. Okay, let's continue. So what if you want to get percentages? You can use prop.table command. Okay, that one there, and then you put in your object and you run it. So this is what you're getting, the percentages. However, you might want to multiply them by 100 and then round off. So what you do, you just get the whole of this command, you put a comma to this, I'm telling R to 2 decimal places, then round off to 2 decimal places, then I multiply everything by 100. So when I run this, it implies that with associate professor, it is 16%, assistant 17%, and professor is 67. This you can do it in on different variables that you're interested in. So when you come to data visualization, I'm just giving a simple introduction, then the rest is going to be covered. So with categorical, you can run a bar plot. When you run that, I'm getting an error. That error in the plot new figure imagine to why it is like that, because remember I zoomed out, I zoomed in. Remember I zoomed in. So I kindly ask you to run this bar plot on your computers and tell me, type in the chat if you've seen the figure on your computers. Yes, prop is the same as proportions. You're right. I've just seen a question. Yes, I've explained why I'm getting an error. If you're an error plot new, you have to zoom out such that you create a bigger space here. That's when this error will disappear. And let me see if in case I try again. Yes, you see, the moment I enlarged the space, I was able to get my output, because why? Before it was giving me an error, the space was very small, that figure margins too large. I can click zoom and then see the different distribution for associate, assistant, and then professor. Okay. All right, so let's continue. You can use the def.off.
Hello, can I have your attention, please? We've noticed that a number of you are not getting the material, and this is probably because your emails contacts are missing on the one that is used to send information. So we are going to send another link for registration, and would also request that you put your telephone contact there so that we have all the information that is required. Thank you.
So have you shared it? Okay. Okay, now let's proceed. We are looking at data visualization. In case you are saying dev.off, this implies in case you want to delete all the figures in the plot window, you can run this command. It will delete everything, that all the images, all the graphs that have been stored off from R. Okay, you can as well also run this command in case you want to change the position of how it looks like. So this is how it will look like. The bars will now look horizontal and the frequency will be on your x-axis. If you're interested to run, because remember when you're dealing with categorical variables, you can run either bar plot or you can put or a pie chart. Okay, kindly run through and check if what I'm having is what you're getting. Also, when it comes to continuous variables, we can plot a scatter plot, and we use the plot command. So I'm telling R that from my salaries, plot for me from my salaries data set, plot for me salary. So if I get that and I run it, you see that I'm getting a plot for a scatter plot for salaries from depending on the data that I have. If you want to see the picture very well, kindly click zoom, okay? Click here, and then the moment you view a larger version of the plot. Okay, let me continue. We looked at how to use the read XL. Professor Susan, are you set? I'm almost done. So now the last bit in my presentation today, you can rewrite the CSV file, or after doing a lot of manipulation, you might want to transfer the data set in R back to CSV or XLS. With the CSV, we use what we call the write.csv command. You put in the name of the data set, you put an argument file equals, and then inside here, you put in the data set name that you want it to be converted to CSV. And the moment you run this line, you will see an updated data set that is in what? In the same folder where you are working from. Other plottings, we'll look at them as we are moving on. And then lastly, in case you've got an overcrowded environment and you want to delete all this particular information and then to clear it again, all you need to do is run rm list equal to ls, and then it will clear. Okay, so you see that now your environment has cleared. So let me ask in the chat if there are some questions, I'll answer them, and then Professor Susan will take over. Could you guys wait for the link to be sent? Okay. Now I can't read the what? The questions, they disappear. They're going to send the link. They're still designing it out, so they're going to send it very soon. Kindly put your emails in the link they're going to send, because I cannot pick them, quickly as such. Okay. And from the link they're going to send, you'll update the registration, and then we are there. Professor Susan, are you set? Okay, let's take a break of 10 minutes. Okay. So let's resume again at 12:06, and Professor Susan will take over. How do we copy pictures in has it disappeared? Let's take a break for 10 minutes, and then we can resume. Okay. Okay.
Good afternoon, participants. Good afternoon. Can we start? Good afternoon. Is everybody there? Can you hear me? Let me see in the chat whether you can hear me. Should I increase my volume or voice? That was a commercial break for you to retire from R. Now we are going to do a bit of theory. After the theory, if time allows, we'll do practicals. If time doesn't allow, then we will do the practicals tomorrow. Okay. Somebody says it's still morning at their time. Lucky you, you're still sleeping. Okay, let's start. We are going to look at data analysis, and the part we are looking at is exploratory data analysis. I assume that everybody has the PowerPoint that I'm using, or the slides that I'm going to use to present. So data analysis is aimed at summarizing the main characteristics of data sets using numerical and graphical methods. It is a critical step in analyzing data. Really? Oh, a minute, just 1 minute. It's in PowerPoint. Okay. Mine is moving. Okay, now I put it in PowerPoint. There we go. Is it moving? It stopped. Huh? Okay, hello. Let me try with the participants. Is the PowerPoint moving? Are the slides moving? Are they moving? Can we see in the chat? Are the slides moving? No. Okay, give me 2 minutes to sort this out. Thank you. Okay. What are we gonna do? Put in slideshow. Is it moving? Oh, click on slideshow. Where is slideshow? Yeah, this one. Is it moving? Okay. Okay, sorry about that, participants. Now we can go on. We're going to look at exploratory data analysis, and I'm assuming that now you can see the slides moving. Are the slides moving? Yes. Okay. Thank you very much. Okay. Thank you very much. So I was saying that data analysis is aimed at summarizing the characteristics of a data set using numerical and graphical methods. It's critical in analyzing data. It is the first step that we perform before you go into hypothesis testing and modeling. It even gives you an insight on what to model and what hypothesis tests to formulate new ones apart from the ones you indicated in your proposal. Data analysis was promoted by John Turkey to encourage statisticians to explore the data and possibly formulate hypotheses. So the importance of data analysis. It's used to maximize insight into a data set. Using data analysis, we are able to uncover the underlying structure of the data. We are able to come up with relationships. For example, in a data set, we have different types of variables. We may have continuous variables, discrete variables. We may also have categorical variables. And depending on the type of variable, we are able to know what type of summary statistics we are going to use. So in exploratory data analysis, we are able to create new variables and also do transformations. You find that once we draw a histogram, you are able to know the distribution of the data set. And if it's non-normal, you can either decide to transform the data set or model the distribution of the data set. By modeling the distribution of the data set, we mean that if the data set follows a binomial distribution, then we can decide to conduct a logistic regression which accounts for binomial distribution. We can detect outliers and mistakes. We are going to see outliers in detail, but those are observations which are different from the rest of the data set. So you can find that if we can give an example of human beings, you can find that on average, a human being may be 5.5 feet, and then you find somebody is 6 point something. So maybe that one becomes an outlier. Okay, so that's how outliers are. Or we find that a lady has children, 4 of them, but one of them eats a lot, then it becomes an outlier. Not because he has a problem, but maybe because of the demands of the body, that person eats double the amount of the food that others are eating. So that one becomes an outlier. So we are able also to test assumptions using exploratory data analysis, and we are able to suggest hypotheses about the cause of the observed phenomena. Because if you come up, for example, with relationships, looking at our data of employee that we are going to use, in that data set, we have gender, we have job category, we have beginning salary and current salary. So we can run a scatter plot, which is exploratory data analysis, between current and beginning salary. And we'll find there is a relationship. So we can formulate a hypothesis that says that there is a linear relationship between current salary and beginning salary, meaning that if we have the current salary of the new employee, we'll be able to calculate if we have the beginning salary of the new employee, we'll be able to calculate the current salary. Okay? So exploratory data analysis also supports selection of appropriate statistical tools and techniques. So once you've done your descriptive statistics, that is exploratory data analysis in form of numerical summaries and graphical summaries, you'll be able to see trends in the data. And now you'll be able to decide the appropriate statistical tools. For example, if we do a cross tabulation of gender and job categories, we are going to end up with 6 cells with counts. So in those cells, we cannot decide that we are going to do an analysis of variance. It is abnormal for you to conduct an analysis of variance for 2 categorical variables. In that case, we will decide that in order for us to establish differences in job category and gender, we will choose a chi-square statistics. But we can only do that if we have done exploratory data analysis. So it also provides a basis for further data collection through surveys or experiments. So in most cases, we find that when you're going to conduct a study or a survey, you go and pre-test your tools. When you come back, run some exploratory data analysis, you're able to know whether the collected data will actually answer your objectives. Or if you've already collected the data and you can't go back, you'll also be able to know whether the data that you collected will answer your objectives or you need more data. Now, if you need more data, that means you're going now to create more questions, research questions that you'll use to collect more data for that particular purpose. So methods for exploratory data analysis. We know that there are 2 methods. We have the numerical and graphical methods. But what determines what to do with your data? It depends on the method of summarizing data. You can either choose numerical. With numerical summaries, we are talking about measures of spread, measures of central tendency, measures of position. Those are the ones we are talking about. Versus graphical methods, where we have things like a box plot, we have a line plot, a scatter diagram. Then it also depends on the number of variables being examined. Sometimes you have only 1 variable at a time, and sometimes you have more than 2 variables at a time. So how do we summarize those? And also, the type of variable determines also the method of exploratory data analysis. For example, with the job category and gender, those are 2 categorical variables. We cannot draw a histogram for job category and gender. We will end up with bars which are separated, and they don't really show the distribution of the data. So in that case, the most appropriate exploratory data analysis would be a bar chart. Okay, so that's how the type of variable determines the type of exploratory data analysis to apply. Now, if you have current salary and beginning salary, then the appropriate type of analysis would be a histogram, because you want to know the distribution of the salary. Or you can use a scatter plot to know the relationship between the 2 variables. Or you can decide to draw a bar graph. But if you decide to draw a bar graph, you're going to lose information. For us to construct a bar graph for continuous data, we have to formulate groups or categories. So we have to formulate ranges of salaries. Then within those ranges, we compute the frequencies, and percentage frequencies then be able to construct our bar graph. So if you're analyzing your data for your research, you cannot select a bar graph for continuous data unless if you've summarized your data maybe by means and you want to present those means in a pictorial diagram. Okay, so let's go ahead. So if we can summarize our methods of analyzing data using exploratory data analysis, and we are looking at the type of variable being univariate. Uni means 1, mult means many, and then we are also looking at non-graphical methods and graphical methods. So if we have a univariate, we can do measures of location under non-graphical, which are means, median, mode, quartiles, and then measures of spread range, variance, standard deviation, interquartile range, and we can also do frequency tables. Now, for graphical methods for univariate variables, then we can do a box plot, histogram, a leaf plot, stem and leaf plot, a bar chart, a pie chart. We are going to see these in details when we are doing the practicals in R. Now, if the data set has multivariate and want to summarize the data, we can do cross tabulation, which can either be between a discrete and a continuous variable, or a categorical and a continuous variable. We can come up with covariance and correlation coefficients. We can do covariance, variance covariance matrices, which we shall see later on as we analyze data. And when we come to selecting the graphical procedures for multivariate data, now we can use scatter plot because we have many variables now. We can use a bar graph, a histogram, or a box plot, as we shall see. So in the chat, is there anybody who has a problem? Is the presentation okay? They are saying share the presentation. Dr. Thomas says he has been sharing. He's going to share again. Okay. Check the chat, please. He's going to share the data set. Make the slides. Okay. Okay. Thank you. Okay. Okay, so in the data set that we posted called employee data set, we have variables of interest. In that data set, the main aim was to find out what are the salary ranges, who gets the maximum salary, does education determine your salary? I mean, if you're highly educated, are you likely to get a higher salary? And if you're highly educated, are you likely to get a better job? So that was the aim of that collecting of that data. There's also a variable minority. So we are checking the minority group. Do they get the same jobs as the majority? And can we use beginning salary to determine somebody's current salary? Jobs, those are questions that you can actually create when you get your data set. You can sit down and look at the data set, look at the variables, and create questions. And those questions actually are going to help you analyze data. For example, does gender determine the job that you're going to do? In this data set, the job categories are clerical, custodian, and manager. Are the jobs equally distributed among male and female? So those are the questions you're asking yourself, and they are going actually to guide you when you're analyzing your data. So these are the variables of interest. So this is the data set. Let me just briefly put in slideshow so that people can see the data set. Is it clear? Is the data set clear? Or you can open the data set. I have not. Oh. Is it showing? Is it clear? It's not showing. Some people say it's slideshow. It says I zoom in. How can I zoom in? Okay, so this is actually how far I can go in the zooming in. So this is the data set I'm talking about. It's called employee data. It has ID, identification number, gender, male, female, birth date, years in school, in number of years spent in school, job category, current salary, beginning salary in dollars, job, time on the job, how many hours do you spend on the job, previous experience in terms of month, and then minority, yes, whether you are minority or not. So I'll go back to my mode. Maybe is that more clearer? I can see that it has increased the size. Not clear materials. Yes, okay. Okay, so Thomas will send the data set. Okay. Okay, so what we are going to do, participants, let us cooperate. So all those who are commenting in the chat, stop commenting for 5 minutes. Dr. Thomas posts the data. So it can stay for 5 minutes and everybody will be able to download. Then after 5 minutes, you go on and now send the comments in the chat. Okay, so let us cooperate so that when we send the files, nobody will again ask for files, because I've been also sending the files since my colleague Helen was teaching. Okay, so I'll go ahead. So we are going to look at summarizing quantitative variable when you have one variable at a time. So as quantitative variables are variables obtained by measuring, and they have decimal places. They range from -infinity to +infinity. Those are quantitative variables. Examples include height, weight, salary, size of head, all those, height of a tree, yield of corn, all those are quantitative variables. Okay, so let's look at quantitative variables. I'm going to, okay. So we can summarize a quantitative variable using a box plot. Now, a box plot is a 5-number summary. What makes this 5-number summary? It consists of the maximum value, it has a minimum value, it has a median, it has a first quartile, and a minimum value. So I'm going to show you what we mean. This is the maximum value. Where you see this line here, the upper whisker end is the maximum value where my cursor is running. Then when I run down with a cursor, this is the third quartile. And when I go here, the dark middle line is the median. Then when I run down on the box, the lower edge of the box is called the first quartile. And then the last value here where you see lower whisker end is the minimum value. So that makes a box plot a 5-point summary consisting of the minimum value, the first quartile, the median, which is also called the second quartile, the third quartile, and the upper value. Now, the difference between the third quartile and the first quartile is called the interquartile range. The difference between the third quartile and the first quartile is called the interquartile range. Now, within a box plot, we are able to spot out outliers. You can actually use a formula to calculate and find out whether a particular value, is an outlier, as we shall see. So on either end, the upper whisker and the lower whisker, we can identify outliers. Outliers are not bad. Sometimes they are genuine outliers, like a human being is very tall, taller than others. That is a genuine outlier. Outliers can be by mistake. For example, instead of recording 2, you record 20. Then that is a mistake and becomes an outlier. Okay? So this is a box plot, and it is used for continuous or quantitative data. So if we get data which is measured and would like to summarize the data, we use the 5-number summary called a box plot. Any question about the box plot? Or is it okay? Can I go ahead? Okay. Okay, so let's go ahead. Fine. Thank you. So we are going to go ahead. We are going to construct a box plot in R later on, practically. So in our employee data, which variables are quantitative? Can I see in the chart, looking at the PowerPoint, which variables are quantitative? Let's see in the chart whether you can actually know that this particular variable is quantitative or not. So in the chart, please, let's see the variables. Yes, salary, current salary, gender, no, time. Okay, okay, great. I am so excited and happy about this. This is really good. Yes, all the variables that are measured are called continuous variables, and they are quantitative variables. Okay, thank you very much. Let's come back to the PowerPoint. Thank you. So when we look at our data, the employee data, gender, because it has female, male, it is called a categorical variable. And because these names are not ordered in any way, they don't have any natural ordering, it's called nominal from the word names. So gender is nominal because we have male, female. They do not have a natural ordering on them. So gender is not quantitative, but it is qualitative, and qualitative with a nominal measure of scale. You know those measures? Types of measures, we have nominal, ordinal, interval, and scale. My colleague Helen has been mentioning that. Educational level, number of years at school is quantitative. Job categories, we can see now we have names, clerical, custodian, manager. This is nominal. Current salary is quantitative. Beginning salary is quantitative. Job on time, time on job is quantitative. Previous education is quantitative. And then previous experience is quantitative. Minority is categorical or qualitative. Qualitative of the nature nominal. Now, if we had a variable, for example, performance at work, and it is in terms of names, and they are measuring performance using the awards you've gotten over the year. So they will say excellent, then they say very good, then they say good, fair, then poor performance. You can see that performance has a natural ordering, and it is qualitative, but with a natural ordering. So in that case, performance becomes ordinal. And remember, I mentioned that the type of variable determines the type of analysis, whether descriptive or inferential, as we shall see. Okay, so that was just mentioning in passing. So here we are just highlighting the variables that are quantitative. And let's go and look at the box plot. Now here, I tried to fix everything in one PowerPoint, and we have the 5-point summary here. The minimum years spent at school is 8. The lower quartile is 12. The median is 12. The upper quartile is 15. And the maximum is 21. So you can see that this is the maximum value, which is 21. And then when we lower the cursor, here we have our upper quartile. Now we find that the median and the lower quartile or the first quartile are the same, 12, 12. And the minimum value is 8 years. Now you see this formula here, upper quartile plus 1.5 times the interquartile range is used to determine whether the points up here are outliers. So it is upper quartile. Our upper quartile is 15. So you can get a rough paper and calculate 15 plus 1.5 times the interquartile range, and our interquartile range is the difference between the upper quartile and the lower quartile. So 15 minus 12. So what I'm saying, our upper quartile here is 15, plus, open bracket, 15 times, open bracket, 15 minus 12, close bracket twice, gives us a value. If these values here are greater than this calculated value, then they are called outliers. So that is on the upper end. Now, in the lower end, we are going to have our lower quartile as the formula minus 1.5 times the interquartile range. That is to decide whether the values that go beyond the minimum value are outliers. Okay, so I repeat, on this side where you see the star cursor moving, we only determine outliers by using the lower quartile. So lower quartile minus, open bracket, 1.5 times the interquartile range gives us a value. If these values beyond the minimum are lower than this value we've calculated, they are called outliers. So outliers can be extreme low values or extreme higher values. Any question in the chat? Can we see any comment? Okay, somebody has calculated the value. How can we check outliers and remove it from the data set? We are just talking about it. We are saying that if you're looking at the upper end of the box plot, we use this formula. UQ is the upper quartile plus 1.5 times the interquartile range. The interquartile range is the difference between the upper quartile and the lower quartile. So anything above this value is an outlier. Okay. So I hope that is clear, and you can now know how to identify outliers in your dataset. Remember, when you identify an outlier in your dataset, don't automatically delete it. What you're going to do is that with your dataset, you go with your outliers, do your inferential statistics with outliers, then remove them, do the inferential statistics without outliers. Compare the parameters. For example, the mean. How has the mean been affected? Has it lowered a lot? Has it increased? So you look at the parameters, the mean. If you're doing regression, we are looking at the slope and intercept. Are they highly affected by the removal of the outliers? That is how you determine whether we can now remove the outliers. After confirming values are outliers, we don't eliminate them there and then. We go and analyze our data with the outliers in, remove them, then analyze the data again, and compare the parameters. If with the outliers, the parameters seem to be appropriate, because when we do statistics, we relate the statistics to the biological process. That is the aim of statistics. So you might find that with the outliers, the average height of human beings actually is correct. And without the outliers, the average height of human beings has tremendously lowered. So in that case, you put the outliers back in your data set and go ahead and analyze your data set with the outliers. Okay? Okay, so let's go to the next slide. So we are constructing box plot for current salary. Current salary is also quantitative. And the minimum salary is 1,500 or 15,750. And the maximum is 1,035. I've now forgotten my, sorry about that. 135,000. We used to do those things when we were in grade 2 or primary 2, but now they've all gone out of my head. Okay, so this is the maximum value. And we have the minimum value. The lower quartile, the median, and upper quartile. We can plot them on the box plot. Then you can also use this formula to determine whether this upper part selected in blue are actually outliers. Our maximum value, and then the median, the lower quartile, and the minimum. So in our exercise, we are also going to explore our data set using the questions that I gave you, but we'll do that after doing practicals in R. Okay. So outliers. We've already said outliers are observations separated from the rest of the values. They are also sometimes called extreme values, unusual values. You need to explore the reason for unusual observation. Maybe it is a mistake, maybe it's genuine. So if it's genuine, leave the outlier in the data set and then analyze the data set with the outlier. If it's a mistake, correct the mistake. Outliers can be of interest, as I've just mentioned, if they are not a mistake. So as I've told you, in practice, we analyze our data with and without outlier and compare the results. So when we compare our results, we are able to know that we need those outliers actually in our data set. So now let's look at the population distribution. The characteristics of the population distribution include the center. Center is the average. Spread, we know spread. Characteristics that indicate spread are standard deviation, variance, range, etc. Then shape, that one includes heaviness of the tails. And if we have many values on the right side, we call that a right skew, as we shall see. And if the many values are on the left side, we call that a left skew. And those heaviness of the tail are actually what we sometimes call outliers. And then we also look at the outliers. So let's look at the characteristics of our distribution. We looked at measures of central tendency. And examples, we gave the mean, the median, the mode. Now, we know that for normal distribution, the mean, median, and mode are similar. Mean is the commonest measure of center of the distribution. And it's obtained by summing up all the values, all the data values, and dividing by the number of observations. Mean is heavily affected by outliers or extreme observations, as we shall see. So if we look at the mean of current salary and years at school, so we are going to see that when we compute the mean of current salary, the average, we have 34,420. The median is 28,000. Remember, the median is not affected by outliers, but the mean is affected. And when we looked at our data set, we found that there was one particular person who earns a lot of money. So it's affecting the average value of an outlier, mean. So if we have variables like income, because they are heavily skewed, you find there are very poor people and very, very rich people. So if you just take the mean as the measure of average income of the population, then we are going to have a wrong value of the average measure earning of the population, because the very rich people are going to influence the value of the mean. So normally when we have a skewed data set, the median becomes the best measure of central tendency, because median is not affected by outliers. But there is also what we call trimmed mean. So sometimes we can decide to trim off 80% of the outliers. Remember, we have a formula for computing outliers. So if we trim off 80% of this data set, you will find that our trimmed mean is almost similar to our median. because we've removed the outliers. The same applies to years at school. The minimum value is 13.49 years. The median is 12. When we trim off 92%, our trimmed mean is almost similar to our median. So we are saying that the mean is highly affected by extreme values. And if you have a data set with many outliers, median becomes the best measure of central tendency or trimmed mean. Okay, so here we have a table here that is showing the percentage of trimming and the mean current salary and the median. So when we have 0 trimmed, our mean current salary is 34,420 and the median is 28,800. When we trim 5%, you see what happens to the mean value? It changes, it is lowering. And the median, almost in the same range. 10%, the mean is changing, lowering, because you're removing those values that influence the mean. And the median, still almost the same. When we do 15%, the mean is lowering. When we do 25, it is lowering. So here, median is a measure of central tendency, is very robust. It does not change as you include or exclude outliers. And you can see the values of the median. They are almost the same. Okay? So this is just showing you that the mean is heavily affected by extreme values. Okay, so in the chart, let me see whether there's any problem. Okay. How can we determine our trimming percentage? It depends on the number of outliers you have. We already know how to calculate outliers. We can decide to do 0%, 10%. You can see that as you increase the trimming, the value of the mean is actually becoming closer to the value of the median. Remember, the median is not affected by outliers. Okay? Okay. So measures of spread. So spread is a measure of how far a value is from the center, how far a value is from the mean. So the difference between the mean and the observed values is the spread. So measures of spread include the range, which is the difference . Okay, somebody has a question about the outlier formula. 1.5 is a constant. It's part of the formula. Okay. Helen is going to share the PowerPoint in the chat for those who didn't get the PowerPoint. Okay. So measures of spread, we have range. Range is the difference between the maximum and the minimum value. Then interquartile range, we've already talked about it. It's the difference between the upper quartile and the lower quartile. Both range and interquartile range do not take into account all data values. You can see if we are calculating the range, we only consider the maximum and the minimum. Interquartile range, we only look at the upper quartile and the lower quartile. So on the box plot, you can see the range, the difference between the maximum value and the minimum. The interquartile range is the difference between upper and lower quartile. Okay. The other measures of spread, we have variance and standard deviation. So the square differences from the center is what we call variance. So when we get the differences between the observed values and the mean and square them up, sum them up and divide by n minus 1, that gives us the variance. And the square root of variance gives us the standard deviation. So if your variance is big, that means that the data values are far from the center. There's a lot of noise in your data. Okay? So we can avoid having a lot of noise by collecting enough information. That means having the right sample size for the right significance level. Okay? So we'll look at sample size later. Measures of spread. So we want to look at extreme values. Do extreme values affect measures of spread? Okay. Here we have percentage of data trimmed off. When we have 0, the range is 13, interquartile range is 3, the variance is 8.3, and the standard deviation is 2.885. When we trim off 5%, the range becomes 11. Remember, range is the difference between maximum minus minimum. So when you remove the range, when you remove those higher values, the range is likely to decrease. And the variance is also decreasing, and the standard deviation. Remember, when you're computing variance, you are getting the difference between the observed and the mean, squaring them up, and then divide by n minus 1, where n is the total number of observations. So it is also likely to be affected by the removal of very extreme values. So as we go on reducing, for example, 25%, we see that the range now is 3, interquartile range remains the same, the variance has reduced, and the standard deviation. So, which of the statistical characteristics are robust to outliers? The range is not, because it is changing every time you remove 1, it changes. The interquartile range is robust. You can see it has not changed from when you remove 0 to 25% of the data values. The variance is not robust, and also the standard deviation, because of the changes. As you remove extreme values, also the variance and standard deviations are changing. So this shows you that when you have outliers in your data set, don't just remove them. Try to find out how they affect your parameters before you remove them. Any question before we go to before we go to numericals? How do we calculate the standard deviation? This is the slide here. I've brought the slide back. The square root, down here, the square root of variance gives us the standard deviation. So we sum up, if we have 4 data values, we sum up from 1 to 4 of the difference between observed minus the mean squared over n minus 1, gives us the standard deviation. Okay, so before we go to graphical summaries, any question? How do we interpret the variance and standard deviation? How do we tell the variance is too big? You should be replying. Okay, I've seen some questions. How do we explain standard deviation in terms of our data set? Now, if the variance or standard deviation is bigger than the mean, then that data has a lot of noise. It's so variable, meaning that the values are far away from the mean. There's a lot of noise, indicating that we should collect more information to reduce the noise within the data set. Okay? So, how do we determine how big? Look at the mean and compare it with the variance. What is the implication of standard deviation, variance, and trimming? Standard deviation and variance talks about the spread, how far the observations are from the mean. If the observations are very far from the mean, that means that the parameters we are going to calculate do not actually represent the characteristics of that population, since the values are very far from the mean, the average value. Okay? So when we get a data set or we collect data set, we want to see that our observed values are closer to the mean. And when they are closer to the mean, we end up getting our normal distribution. If the values are very far from the mean, then the distribution actually tends to go further away from the normal distribution. Okay? So when we have very many high values, then we are going to have skewness in our data set. Okay? Okay. Yes, we can use a box plot to present data in chemistry. How? Okay, so let's go ahead. So we are going to look at graphical summaries for one particular variable. So in this case, we are looking at the shape of the distribution. If we look at our two graphs, we have one which is uniform, no peak, and one which is peaked. And we see that from the shape of the distribution, it's almost normal. Okay? So this is the peak. Where you see the cursor moving is the peak. And you can see that if we draw a line in between, this other side is equal to this side, meaning that this data is normally distributed. So in the shape of the distribution, we want to see whether our histogram has a normal distribution or it is skewed, and if it is skewed, to which side? Is it to the right, to the left? Is it positive or negative skewness? So we can see that the blue histogram shows us the two tails, the left tail and the right tail. But if we draw a line in between, we will find that the two parts are almost equal to each other, meaning that our data set is symmetric. And the two tails, left and right, are almost similar. They are almost equal to each other. So meaning our data is not skewed. So this is symmetric, and symmetry means that when you divide this plot into two, the right side is equal to the left side. Now, when the data set is skewed or non-symmetric with one peak, you can see the left tail is shorter than the right tail. The right tail is longer than the left tail. So because the right tail is longer than the left tail, we say the data is skewed to the right. Okay, let's look at this one. Now, when the left tail is longer than the right tail, then we say the data is skewed to the left, or it has a negative skewness. When the right tail is longer than the left, then we have positive skew or right skew. So in this tail here, we have our values which are extreme or outliers, and we can always confirm using the formula I've just shown you. So using our data set, can we investigate and look at the distribution of the data? Here we have current salary. When we plot current salary, we see that the left tail and the right tail are almost the same, or they have similar length, indicating that our variable current salary is normally distributed. And in this case, the median and the mean are approximately the same. So if we look at the magnitude of current salary, the minimum is a minus. The first quartile, you can see the value. The median is 33,370 or 33,700. The minimum is 33,940. So you can see the median and the minimum are almost the same. So if you find such a case, then the data set is normally distributed. Let's look at skewness. Okay, so you can see in this graph here, we find that our left tail is longer than the right tail, meaning we have a left skew. So in the left skew, the median is 2888 and the mean is 34,420. The minimum, the average value is greater than the median in the left skew. Let's look at the right skew and see what happens. In the right skew, the left tail is shorter than the right tail. The median value, the mean is less than the median. Okay, so if you're given values in a data set, it has been summarized, you can know that actually you have a right skew or a left skew. So in the right skew, the mean is less than the median. In the left skew, we saw that if we go back a little, we saw that our mean was greater than the median. So then how do we summarize qualitative variables? Qualitative variables, we don't need to look at the central tendency. You can imagine if we are going to look at central tendency of gender, how does it sound? So with the qualitative variables, we don't look at central tendency, spread, and skewness. They do not have a meaning for qualitative nominal variables or ordinal variables. Sometimes it makes sense for ordinal variables, not all the time. So you have to use your personal judgment to know whether you should really present central tendency for things like performance, if it is in terms of words like excellent, very good, good, poor, fair, and poor. Okay? So then how do we summarize qualitative variables? With the quantitative variables, we are able to determine the minimum, the maximum, median, mean, quartile, range, all those. So let's see with our quantitative variables. In our data set, the variables that are qualitative include gender, job category, and then minority. You can see all of them have one thing in common. The data is measured in terms of names. The names are given to the observed values that we enter into the computer. So how do we summarize? We look at frequency tables. We can use pie charts. A frequency table consists of the category and the number of counts that correspond to that particular category. A pie chart consists of slices corresponding to the categories. And those slices indicate the percentage of each category. Then a bar graph has bars where the length of the bar is equal to the percentage frequency of that particular category. Okay, so for gender, for us to summarize gender with a frequency table, you can see in this table here we have gender, female, male, and we are given the frequency, that is the number of female, the number of male, and we can calculate the relative frequency, which is the frequency over the total number of frequency. So relative frequency for female is 216 divided by 474. Then you get 0.45. You can convert this to percentage. Okay. Then we can have a pie chart or a bar chart. So we have female, male again, and you can see in the pie chart, the slices correspond to each category. But when we are presenting our data, a bar chart is preferred to a pie chart. Okay? So in the bar chart, we can see that the male bar is higher than the female. And in the magnitude, we find the female are 45.6%, while the male are 54.6%. So in this data set, there were higher number of male compared to the female. So here we can't actually draw a histogram of gender. That would look funny because you still have these two bars and which do not have any meaning. So we have another relative frequency. We can actually multiply by 100% and guess the percentage of female in that particular data set. So it is a way of summarizing the frequency that you have. You cannot present frequency in your write-up. So when you're presenting your results to an audience, it is quicker for somebody to understand percentages as compared to the counts or frequency. So that's why we have relative frequency. Okay. Then we have job category. It's also qualitative. There are 3 categories. And we find that the highest number of people are clerical and the least is manager. Why do you think we have fewer managers? The answer is there. They are highly paid. So if you have so many managers, that means the company is going to spend a lot of money on managers who are unnecessary in our company. Why do we have many clericals? There is a lot of work which come typing, taking letters around. All those jobs require many people to do them. Custodial. Why don't we have so many custodians? In a building, the maximum number of custodians I've seen are 2, at least here where I am. So if you are going to have 4 custodians in a place, that is going to be a crowd. So that's why we see we have fewer custodians compared to the rest of the categories. So you can see that the descriptive statistics we are doing or exploratory data analysis is showing us the trends, the differences. Are there differences in job categories? Yes. We can see that they are more clerical than managers. Are there differences in gender? Yes, they are there. So those differences are the ones now trigger the inferential statistics. They are the ones which tell you, should I go for chi-square? Should I go for t-test? Should I go for ANOVA? Or should I do a regression? So, coupled with the type of variable, you're now able to determine the type of inferential statistics to conduct on your data set. So in this case, we want to find out, does gender, being a female, does it determine the type of job that you hold? Are there differences in job categories among the gender? So if we want to find out whether statistically there are differences, we will run a cross tabulation of gender and job category, and then run a chi-square statistics, chi-square test of independence. It's going to tell us within those cells there are differences, and which particular job category has fewer people. We will be able to tell when we do a cross tabulation. Okay. So we have minority, yes or no? Are there more minority in the company or no? So when we look at the minority, there are fewer. Okay? And we are seeing a 21.9% number of minority. This is a data set from the US. That's why we have minority. I don't know whether in Africa, do we have minority? I'm not sure. I'm not sure. I don't know. Don't quote me on that one. So we can present our data set of minority. Sorry. We can present our data set of minority in terms of a graph. So we can either use a pie chart or a bar graph. But a pie chart, a bar graph, is a better pictorial presentation compared to a bar chart. a pie chart. Okay. So how about if we have more than one variable? We want to explore the relationship between two variables. I've been talking about gender and job category. We want to find out, is there a relationship between gender and salary? Is there a relationship between job category and salary? Does a manager earn better than a cleric? Or does the cleric earn better than? Those are the questions we are asking ourselves. And when you have a data set, that's what you should do. Ask yourself questions. And those questions are going to guide you in your analysis. And as you analyze data, you become interested in the data set. It becomes part of you, and you're able to think more, to synthesize the data more than when somebody gives you a data set. Like if somebody brought their data set for me to analyze, I'm not going to put my brain in it. But if the data set is yours, you're going to put all your energy in understanding that data set. Okay? So in the chart, let me just look at the chart. It's saying you cannot see them if you're using a It says I put the presentation in slideshow. Okay. Because the slides are being cut off. No problem. Let me do that and see whether it will move. If I put it in slideshow, are we going to have these slides move? Okay. Are they moving? I need answers in the chat. Are the slides moving? They say no. So if the slides are not moving on your end, that's why I'm putting my presentation in this mode and increasing. Actually, I've increased the zoom. Okay, so I'm sorry for those who can't see using their phones. I think my computer has a problem with PowerPoint, which will be sorted after this. Tomorrow we'll have a better view of our PowerPoint. Okay, let's look at relationships between two variables. So if we want to establish a relationship between a qualitative and a quantitative variable, here we are looking at job category and current salary. Remember the job categories, we have cleric, custodial, and manager. And we want to present them in a graphical way. So we can use a bar chart. Remember here in a bar chart, our measure is going to be the average current salary for each group. We are not going to use percentages because our other variable is continuous. That's why we are using the average, or we can use the median. So from this bar chart, you can see that the cleric, the custodial, and the manager. Let me go to the next, then I explain better. So if we use a cross tabulation of job category and current salary by job, we will see that the manager, even when it comes to the minimum value, earns better than the custodian and the cleric. When we go to maximum, still the manager is earning better than the custodian and the clerical. Who earns least? It is the custodian. Reason? We need to go and investigate. I don't know why they are earning less. So we have the first quartile, the median value, and the minimum value. So I can actually expand this, and we see whether the values will be visible, more visible to those people who are using the phones. Okay, so we have our minimum value. The minimum that a clerical earns is 27,840, and then a custodial earns 30,940, and a manager earns 63,980. This is actually annual pay, not monthly pay. Okay, so we can actually present this information in form of a box plot. But in your research, if you decide to use a table, don't draw a plot for the same information. It becomes boring. So in your research, you decide either to use a box plot or a table, because it's the same information you're presenting. So the same information presented on the box plot still shows us the manager. This is the top box for the manager, earning better than the custodial and the cleric. The box plot also shows us the spread. You can imagine the black line here shows us the median value, and the difference between the median value and other observations is showing us the spread. Okay, so you can see that our data set of manager is skewed to the right. You can see the longer tail goes to the right. Then when we look at custodial, we can't really, it seems like it's more normal than compared to the rest. When we look at clerical, still we have a longer tail. From the black line going this way, the longer tail is on the right, meaning it is also skewed to the right. Okay. Now, if this part here, from here going this way, from the black line going on the right is equal to from the black line going to the left, then we have symmetry. We have normal distribution. Okay. Any questions so far? No question? Okay, so far so good. Okay. Okay. So here we are looking at summarizing a quantitative variable and a qualitative variable. How do we summarize such data? We can use either cross tabulation of the categorical and the quantitative variable, or we can use the box plot. So you can see that the clerical has the minimum number of years spent in school. The custodian spends more number of years than the clerical. The manager is spending higher number of years in education compared to the rest of the groups. So, does number of years determine the type of job that you get? Those are the questions that you have to think about. And if so, does this also affect how much you're going to earn? Okay, so we can jump this one. So whatever I think, okay, let's look at relationship between qualitative by using a box plot. And you can see we are looking at gender and current salary, and also gender and education. So if we look at gender and current salary, which gender spends more years in school? It is the male. Why? Because the female have to go and get married. Don't you think so? I think so, that the female have to go get married. The male, some of them decide to get married at 40. The women are saying, okay, maybe there's another reason, but that was the quickest thing I would think about. Then education of managers by gender. So we can see that we have selected only managers, and still the men are spending more years in school compared to the female. We can actually conduct an online study and find out why do the men spend more years in school. Okay. Setting, close that. Just a minute. Dr. Thomas here wants to sort out the problem. You try later. Okay. It's going to work. Are you able to see? Are they moving the slides? From your end, are the slides moving? Let me see in the chat. No, they are not. So let's go back. Okay, thank you so much. And let's continue. We have a few minutes to go to end our show. So we're talking about the number of years spent in school, and we see that actually the men are earning more than the female. They are spending more years in school than the female. And me, I thought that it is because we have to get married at a younger age so that you can give birth early enough and then go back to school. Okay, so some people are saying that it is what? That I'm discriminating. I'm not discriminating. Okay, so we can also look at the distribution pattern for qualitative variables, and we can use the frequencies and relative frequencies of the observations for each category. So if you look at the frequency, if we look at the frequencies for each category and calculate the relative frequency, and I told you relative frequency is obtained by getting the frequency for the particular category divided by the total frequency. For each cell, we can compute the frequency. Now, when we look at also female male, we can have our relative frequency. It is just telling us relative to other categories, how big is a particular category. Okay, so we are interested in looking at the distribution of these two variables jointly. Is there an association between job category and gender? Are males and females equally distributed in the different job categories? Those are questions that you ask yourself. If they were not predetermined questions, you can actually bring them in as you analyze the data. So when we look at our two categories, gender and job category, these are the frequencies, male and female. Let's look at the relative frequency. So we can see that under custodial, we don't find any female. And then under manager, there are fewer female compared to the male. And clerical, we find more female compared to the male. If you look at the relative frequency, you can see clerical, female we have 0.435, which we can actually convert to percentage, and we have 43.5%. Meanwhile, male we have 33.1. Okay, so let's go ahead and look at the joint distribution of the job categories. So if we look at the female only, custodial, no female, clerical, higher, manager, fewer. So there are fewer female managers. We need to investigate why. I want to give my opinion this time. Okay, then when we look at the male, they are all distributed across all jobs. We have male clericals, we have custodians, they are only male there, and managers are more male as compared to the female. So you can present these graphs and start writing a story around them. So when we want to look at the marginal distributions, the total distributions, and how they vary among the two, we can look at one variable at a time. If we look at the female male gender down here, we see there are fewer female compared to the male. And when we look at the totals here for clerical, custodian, manager, we've already seen that there are more clericals as compared to the rest. So if we convert these to relative frequency, we can ask ourselves a question. Are jobs distributed equally between male and female? Can I have some comments? Are jobs equally distributed between male and female? Okay, so can we also have reasons why the jobs are not equally distributed? Assuming this is your project and you're writing to the World Bank, why there's unequal distribution depending on the type of job. Okay, custodians might, gender roles, okay, societal levels of education differs, that is true. Skill set, yes. Qualifications, yes. Discrimination, no. Specialization, yes. Female despise some jobs, yes. Fewer years in education, wow. Nepotism, okay. Thank you so much. Okay, great. Attitude, stereotype, gender mainstreaming policies. Thank you very much. So we can write a story, we can write a report to the World Bank, telling them that the female, the jobs are not equally distributed among male and female, and we give those reasons. Okay. So let's look at the distribution of one variable for each level of the distribution of the other. So if we look at the distribution of gender and look at clerical, we will see that there are more female clerical as compared to the male. When we look at custodian and look at gender, no female are indicated here. When we look at manager, fewer female. Okay? So showing us that there's unequal distribution of jobs among female and male. So we want to lastly look at relationship between quantitative variables. We've looked at two qualitative variables. We've looked at a qualitative variable and a quantitative. Now we also have to look at quantitative and quantitative. And what are the quantitative variables in our data set? We have educational level, current salary, beginning salary, time on job, previous experience. So there are various ways we can summarize our quantitative variables. We can establish relationships between number of years and current salary. Does current salary depend on beginning salary? Can we use beginning salary to determine the salary of the incoming employee? Does the current salary depend on previous experience? Okay. So how can we do those relationships? We can use a scatter plot. Under the scatter plot, one variable is on the x-axis and the other variable is on the y-axis. The x variable is sometimes called explanatory, independent, input, depending on the type of software you're using. Then the y-axis has dependent variable, outcome, or response, depending on the statistical software you are using. Okay. Is there a relationship between educational level and salary? This is the graph. Is it visible? Should I zoom in? I've zoomed in. Is there a relationship? Do we see any relationship? Let me see in the chart. Do we see any relationship in that graph? You don't see a relationship. Can we see reasons? Zoom in more. There we go. Okay, so do we see any relationship here? Yes. What type of relationship do you see? There's a relationship. A positive relationship, a linear relationship. Okay, linear. The higher the educational level, the higher the salary. Wow, that is super. Excellent. Okay, so we see that there's a linear relationship between salary and educational level. And some of you have been saying that the more number of years you spend in school, the better the earning. Okay? Of course, this is true. If somebody has spent 2 years in school, they cannot automatically make them manager unless if they are the owner of the company. Okay? So if they own the company, then they can be manager. But behind him, who is less educated, there are so many highly educated people who are actually advising him. So he's a manager, because he's actually owns the company. Huh? Okay, so how do we explain the drop after 20? So these are outliers, you can see. Yeah? Here, these are outliers. And we also have some outliers here. Okay. Okay, so let's go and look at another relationship. So you've been saying the drop, yeah, it has been highlighted as outliers. There are values which are far away from the other. You see that most of the values are concentrated between 12 and 18, and these ones seem like outliers. We can actually confirm that they are outliers, but you can see these ones, they are far away from the rest of the observations. Okay, then a relationship between beginning salary and current salary. So what type of relationship do we see in the chart? Let me see. What relationship do we see between beginning salary and current salary? Somebody is saying cannot see, but you have the notes. Okay, so that is the chart. Positive, linear, positive. Is it strong? Okay, great. Thank you very much. We can see that we have a strong positive relationship between salary, current salary, and beginning salary. But even within this graph, we can see there are outliers. You saw there was somebody getting 135,000 compared to the rest. You can see is an outlier here, and also we have some outliers there. So we can confirm using that formula whether those are outliers. Okay. Then we can also produce multiple scatter plots. So these are between all the quantitative variables. If we look at them, let me increase the zoom. So we see that this is current salary here. We have beginning salary, the second one. We have years in education, and then we have time on job and previous experience. So you can see that current salary, this is current salary and current salary. That's why it has a perfect relationship. I mean, current salary and beginning salary, they have a strong positive linear relationship. Then we have current salary and years in school. The relationship is not really, there's a very poor relationship, not linear, maybe not correlated. Then we have time on job and current salary. There's no relationship between time on job and current salary. And when we look at previous experience and current salary, we have, maybe if we make it bigger, we will see there is a relationship, a linear relationship, but I think the number of outliers are really affecting the shape of this plot. So you can also look at other variables, beginning salary and years in education, same structure. Then when we almost have the same plots, actually, when we look at these plots. Okay. Okay, so we have also other ways of summarizing quantitative variables by using correlation and covariance. Covariance is a measure of how much two variables vary or co-vary. That is to say, how much and in what direction should we expect one variable to change when the other also changes. So if current salary changes, how much is beginning salary going to change? The units of covariance are products of the units of the variables. Correlation is a standard measure of linear dependence. Remember, correlation shows us the relationship between two variables. Is it a strong relationship? Is it a weak relationship? When we have a random scatter of points in a graph, we say that there is no correlation. But we saw that in our graphs here, we saw that current salary and beginning salary show a strong positive linear relationship. Now, if we look at the magnitude of that relationship, we also find that it is actually higher than 0.7. Now, if we look at a relationship of current salary and, let's see, sorry about that. I moved so fast. So if we look at current salary and time on job, you will see that there is no relationship between current salary and time on job, because you can see it's a random scatter of points, and we can also say that actually one group here, one data is concentrated on this lower part of the graph as compared to these other values. Okay? So we saw that the relationship between current salary and beginning salary was very strong. Now here we've come up with a correlation, which is a measure of linear relationship between current salary and beginning salary. We see that is really the magnitude between those two variables is big. And when we are looking at correlation, some books say that if the value is higher than 50% or 0.5, then that is strong correlation. Others say if it is greater than 0.6, then that is strong correlation. So depending on what book, statistical book you have, when you're doing the interpretations, please quote that book that you've used to do the interpretation. But here we can see that our value is higher than either 0.5 or 0.6, indicating there's a positive, strong linear relationship between current salary and beginning salary. Okay, here now we have values of correlation with the plots. Let me try to see whether I can put them back. So this is the one we've just seen. It is 0.880. Now, with the current salary and current salary, the correlation is 1, which is perfect. Correlation doesn't have any meaning because you're correlating a variable by itself. When we look at years in education and current salary, the relationship is still positive and also strong, 0.66. When we look at time on job, as we said, the relationship is weak. The correlation value is 0.084. So you can see that with the diagram, with the plot, we are able to tell whether we have strong correlation, weak correlation, or moderate correlation. Now here, under previous experience and current salary, the relationship is negative. You can see that minus sign, and it is weak. It is 0.136. So the relationship between previous experience and current salary is minus. Okay. So this is the same information but presented as a table. So as I said, if you want to present your information as a table, use a table alone. If you want a graph, use a graph alone. Don't put the same information in the same document, being summarized by two different things, a table and a graph. Choose one of them, whichever makes your life easier, whichever shows the values easily. Okay? So you can see that the values we've been seeing here are the same values on the graph. Okay? So previous experience is weakly correlated to current salary. Oh, okay. So it appears like I've come to an end. I was still enjoying myself. What do you what do you think, participants? Are you enjoying yourselves? It appears like we've come to an end and it's coming to 2 and we cannot start R now. Unless if you don't want to go for lunch. Here it is lunch time, but my colleagues have stabbed me the whole time I've been here. They've not given me food. Okay, so that is exploratory data analysis. We are going to look at the practical part tomorrow. But before we look at the practical, I sent an exercise. Can you try and do that in R? Try and do it. Will be beneficial to you. When you come tomorrow and we just revise, you're going to understand the practical part of it better than when you just come without doing the exercise. So my colleague Thomas is going to post the exercise. The file is called exercise. So if you can first stop and then they send the exercise, we have our 12 minutes for you to capture the exercise. Try it with R. Then tomorrow, 2 people who will have finished the exercise will present for us. Thank you for being very, very attentive and good participants. You've done a great job. I've enjoyed myself. I was still scrolling the slides and they ended. So the exercise file, Dr. Thomas, can you resend it? Please resend. So you can see that with exploratory data analysis, we can do a lot. We can write a story. Research is the story, and it becomes very interesting when people can read what you've written and understand it. And without knowing statistics, the story becomes too difficult. You take a longer time to finish. So you have a very good chance for you to improve on your research and also improve on your completion rate. Improve on the time you will take to finish. So tomorrow we are going to use our data set called employee. What we've been talking about in theory, we are going to put it in practice. So that by the end of exploratory data analysis, we have actually understood what we can do with our data. Now, the other hand, on Saturday we have presentations from you people this time. A few presentations randomly selected. So you can actually, the knowledge you've gotten now, you can, when you go home, practice with your data set. Yes, it is possible with animal science too to do descriptive statistics. And soil science and medical statistics, medical field, we can also do exploratory data analysis. For any field, exploratory data analysis is the initial statistics we do before we can do inferential statistics. Asking if you will be given certificates, I'll find out. My job is only to pass on my knowledge to you. Can you send that link? What is the link for? Okay. Okay. Okay, I'm told that a link is going to be sent out for you to update the information about email and telephone so that nobody misses material the next day. And for the 2 days we've had since Monday, we are also going to create a link. We are going to create a link and post the day 1 and day 2 information. So you'll be able to receive. But if you go to YouTube now, you'll see me live. Okay? You'll see me talking right now. Even afterwards, the link for YouTube is going to stay there. The video is going to stay there for your reference. Okay? So when we finish, you can go to the video for today and revise so that tomorrow things become easier for you. So is the link ready? Okay, so the link is going to be sent together with the material. You will receive it. And I would like to retire today. Thank you so much. You have been very wonderful, excellent participants. I've enjoyed passing on my knowledge to you. I hope you've also enjoyed. I hope it is a two-way traffic, not one way. One way is not good. You don't return. Okay, somebody is saying exploratory factor analysis. That is multivariate. Multivariate is going to be among the last topics to be presented. Okay. Thank you, thank you, thank you. And I would like to say bye-bye. See you tomorrow. Try to attempt that exercise and things will be easy for both me and you. Okay. Bye-bye. Okay. There's a link being sent. What is this link for? Ah. Bye-bye. Bye-bye. Okay, so see you tomorrow with the practicals in the morning. Time is 10 a.m. Please keep time and don't come later and say you didn't receive material or you are lost. Please, I don't want anybody lost. We also all have to be found in ARA tomorrow. Okay, enjoy the evening if it's evening in your countries, or enjoy the morning or the night, depending on where you are. Bye-bye for now. I am going to stop sharing and I am also leaving. Okay, bye-bye.